Hello everyone, let's go ahead and take a look at properties of expectation and the variance. Now, of course, we said that the mean was going to be equal to mu, which is going to be equal to the expectation of a discrete random variable probability distribution. And we can calculate that by taking the summation of x sub I times it by the probability that your discrete random variable actually takes on that particular value of x sub I. The variance, on the other hand, is going to be the standard deviation squared, and that's going to be equal to x sub I minus the mean quantity squared times it by the probability that your discrete random variable takes on that particular value of x. Now, we showed that we can actually go ahead and rewrite that in a slightly different form, and that form is going to be x sub I quantity squared times its probability minus the mean quantity squared. And of course, if we go ahead and write that in terms of expectation, that's going to be the expectation of x squared minus the expectation of x quantity squared. Now, there's going to be a couple of other additional properties of the expectation that we need to go ahead and take a look at and also be able to apply. Now, we're going to assume that k is going to be any constant. So the first property that we want to take a look at is E of k, the expectation of k. Well, that should just be equal to k. The expectation of the scalar product of kx should be equal to the k times it by the expectation of x. And lastly, we have the expectation of two functions ax plus bx should be equal to the sum of the expectations of those functions. Now let's go ahead and take a look at the proof of A and B. In terms of the proof of A, where it says that the expectation of a constant should be equal to that constant, well, this is the way that that graph, the probability distribution table actually looks like. The only value of x that you have is the constant, and the probability, of course, of getting that is 1. Therefore, by definition, when we go ahead and take a look at the expectation of k, which is the only value that you can come up with, then of course that's going to be the sum of x sub I times it by the probability of your discrete random variable being that particular value of x. And sure enough, that's just going to be k times 1, which is going to be equal to k. So the expectation of k, of course, should be just k. Now, let's go ahead and take a look at this one here in B. This is what B looks like. Take a look at the probability distribution table here. So we have x, and let's just say that we have a and b. If I take the scalar multiple of k and multiply it to x, I get ka and kb. And then let's just say that the associated probabilities for getting a and b is p and q. Now, we're going to go ahead and show that this particular equation here is actually going to be true by looking at the left and the right hand sides separately. So if I take the expectation of k times by x, I'm going to go ahead and take these particular values and multiply it by its associated probabilities. So Ka times it by P plus Kb times it by Q. Now if I go ahead and take K times the probability of the expectation of X, then I'm going to be using these values here. So K times it by A times it by P plus B times it by Q. And of course, by a simple factorization or distribution of K, we can see that these two are in fact equivalent statements. Now we'll go ahead and take a look at C, let you guys go ahead and try that one in class. Okay, let's take a look at an example of how we can then go ahead and apply these particular probability properties of expectation to a particular situation. So let's say, for example, that the expectation of x is equal to 3, and it says find the expectation of y if y is going to be equal to 4x minus 2 over 3. Now, if we're trying to find the expectation of y, then of course the expectation of y is the same thing as the expectation of 4x minus 2 over 3. Now I'm going to rewrite that just slightly differently so that it's a little easier for us to see and use. So this is going to be the expectation of 4/3 x minus 2/3. And if we go ahead and take a look at property letter C, then I'm going to go ahead and break that up to say that this is the expectation of 4/3 x plus the expectation of negative 2/3. Now, if I go ahead and use property B, the expectation of 4/3 x is the same thing as 4/3 times the expectation of x. And if I use property A, of course the expectation of negative 2/3 is just negative 2/3. So what I have now is 4/3 times the expectation of x minus 2/3. We knew from the given statement that the expectation of x was equal to 3. And so I have 4/3 times by 3 minus 2/3. Simplify that, you come up with 3 1/3, which is of course going to be the expectation of y. So that is how we can go ahead and use the properties of expectation to go ahead and determine expectations of discrete random variables that are related in a functional form. Okay, we'll go ahead and take a look at variance in just a moment. Okay, let's go ahead and continue with variance and the properties of variance. Now, the one property that we're going to take a look at is the variance of ax plus b is going to be equal to a squared times by the variance of x. Now, in order to do this, we would usually show a proof, but we're going to leave that proof up to you to go ahead and take a look at. Now, how do you go about applying this particular rule? And let's just go ahead and take a look at an example. If the expectation of x, say for example, is equal to 5, and the standard deviation is equal to 2, then find the variance of y if y is going to be equal to 2 times x minus 1, all divided by 3. Now the one thing that we need to remember is that if the standard deviation is equal to 2, that really means that the variance of that particular discrete random variable is actually going to be equal to 4, or the square of 2. Now, the variance of y, which is what we're looking for, of course, is going to be equal to the variance of 2x minus 1 over 3. And then I'm going to rewrite it again so that it's a little bit easier for us to see. And this is going to be equal to the variance of 2/3 x minus 1/3. If we go ahead then and use this particular property of variance, we know that that's then going to be equal to 2/3 quantity squared times it by the variance of x. So what I have now is that the variance of x, of course, we know is going to be equal to 4. So now the variance of y is just simply going to be 16/9. Okay, so given the properties of the expectation of x and the variance of x, we can now go ahead and associate different discrete random variables and find relationships between them using functional notation. And by doing that, we can then go ahead and still use the properties to determine the variance of each one of those different variables. So we'll go ahead and take a look at some of those problems in class the next time that we meet, and we'll take a look at the further proofs that we want to see. So until next time, see you later, bye-bye.